Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. So here we're going to talk about the problem of the day 8. The problem is prove the line passing through the intersection point of the diagonals of a trapezoid and the intersection point of the extensions of its non-parallel sides bisects the two bases. It's from Kyiv Math Computation in 1954. So basically, it's saying that if we have a trapezoid, let's draw it. For example, this is our trapezoid. We call it A, B, C, D. And we want to find the intersection point of the diagonals. So we connect AC here, we connect BD here. This is a point, right? Let's call it point E. And also the intersection point of the extensions of its non-parallel sides. So we extend the BA and CD. So let's call this point as F. And it's saying this line passing through these 2 points. Right, that's the line we're talking about. Let's call this point as M, this point as N. And we want to prove that this line bisects the two bases. So basically we want to prove that EF bisects AD and BC, right? So for this problem, the first thing that we notice is that AD is in parallel with BC. So what we can get here is that AM, because AD is in parallel with BC, so we know that this angle equals to this angle, right? And this angle equals to this angle. That means the triangle AEM is similar to triangle ENC, right? So let's see, triangle AEM is similar to triangle CEN, and also triangle DEM is similar to triangle DEN, right? And also triangle ADE is similar to triangle CBE, right? So this triangle is similar to this one, this triangle is similar to this one. That's all we get here. So think about that. We want to prove M and N are the midpoint of AD and BC respectively. So we can simply find the ratio of AM to BN, right? Because we already know that AM to NC or CN, that equals to ME to EN. Right, and because AM is in parallel with BC, so we know that AM to BN equals to AM to BN equals to AF to BF, right? Which equals to AD to BC. Right, this one to this one equals to AD to BC. And if you look at EM to EN, EM to EN, EM to EN, it equals to. So basically we want to prove that ME to EN equals to AD to BC, right? Because we want to prove NC equals to NC equals to BN. So these two has to be equal, right? And what we have here is AD to BC, and we want to prove ME to EN equals to AD to BC, right? And AD to BC, that equals to AE to EC, right? Because triangle ADE and triangle ADEN triangle CBE are similar, right? So AD to BC equals to AE to EC, right? And AE to EC equals to EM to EN, right? Equals to, which equals to AM to MC. NC, right? Which means AM to BN equals to AM to NC. So we got BN equals to NC. And because BN equals to NC, we directly get that AM equals to MD. So M and N are the midpoint of AD and BC respectively. Okay. So you can see this is a very, very simple problem. It's from like 70 years ago, right? So at that time, I think people don't have so many materials and the problems are simple, but nowadays it's so different. Okay, I hope you like this video. See you in next one. Thank you.